Hi everyone, welcome to video 3.9. In this lesson, we're going to find what geometric properties exist to prove lines parallel, unlike what we did in the last lesson where we focused more on the algebraic side of things. For our notes today, we are on page 225. Really, we only have one lesson goal for this video, and that is to apply angle relationship theorems to identify parallel lines and to find missing values around problems of that type. So we start off talking about corresponding angles being congruent when the lines cut by the transversal are parallel. So when we have those markings on lines, we know that a transversal that cuts across it, just as a reminder of the visual we're talking about here with the word descriptions, corresponding angles end up being congruent. The points of the compass, remember, corresponding angles is how we tie that together. So our northwest corners there are going to be congruent angles. Well, the converse of that relationship is also true. And for this, we want to dig back into our earlier lesson on converse. Remember, if we have a conditional statement that says if P then Q, our converse of our statement reverses the statement that is the hypothesis P and conclusion Q in different places. We start if Q, then P. Okay, so we're basically flipping the logic around in the other direction, remember. The converse of that relationship with corresponding angles is also true. Let's see if we can talk about some new theorems here. So our first theorem is if two lines are cut by a transversal so that corresponding angles are congruent, then the lines are parallel. And if you wanted to put a little sketch next to this, we would be starting with knowledge about the lines, not having those arrow markings to begin with, but if my transversal comes across like so, and we know that corresponding angles are congruent. We know about the angle relationship first, then we can conclude that the lines are parallel. We also have another postulate called the parallel postulate. If you're given a line and a point that's not on the line, so in this case, you're given line M and a point P, then there is only one line that can go through point P that is also parallel to that original line M. Now we know that parallel lines that are cut by a transversal create not just corresponding angles, but several pairs of congruent angles, right? Don't forget we have our alternate interior, exterior, same side interior, and of course, if we have a perpendicular relationship, that happens sometimes too. Well, these special angle pairs can be used to prove that a pair of lines is parallel. Let's see how. Theorem 3.20, the alternate exterior angles converse. And you guys are welcome to go ahead and refer to this by an abbreviated name if you wish, which can just be the acronym alternate exterior angles. And then we'll put an extra C at the end for the converse name there. That tells us if we know there's a relationship so that we're locating a pair of alternate exterior angles and we know they're congruent, then that can tell us the lines are parallel. In this particular diagram that we have here in the sidebar on page 225, the numbers are labeled as they are. And so if, for example, we knew that this angle 1 was congruent to angle 5, this would be an example of the alternate exterior angles converse. Our conclusion would be that the lines are parallel. Continuing down that page, we have theorem 3.21. We can go ahead and call that the same side interior angles converse. So there's the acronym for that. Remember, as we did with our lesson on parallel lines and transversals earlier, we want to make sure that we are shifting the name for consecutive to same side. So as you've seen me do here in orange, make those changes in your book as well. The example here, remember, same side supplementary with that alliteration from our previous lesson. If we have two lines and a transversal, and we know that the angles that are in the locations for same side interior, so for example, yes, 7 and 6, if we knew that those two angles together added to 180 or were supplementary, then that would prove that lines A and B were parallel. Our next theorem that is a converse is our alternate interior angles converse. So again, we're just putting converse at the end of the acronym for the name of the angle pair, which is all about their relative location to that transversal and each other. If we know that two lines in a plane are cut by a transversal, so that in the diagram, the location of alternate interior angles is congruent. So in our particular diagram, an example of that would be angle 7 and angle 3. If we knew that pair of angles was congruent, then that would also prove the lines were parallel. And finally, talking about perpendicular relationships, if we have two lines in a plane that are perpendicular to the same line, then those lines are parallel as well. So again, a picture there would be we do not yet have those arrow markings on these lines, but we know that we are perpendicular to one of those, and we're also perpendicular in that location as well. So these two lines here are perpendicular to the same line, then what that would conclude is that those lines were parallel. Then you can go ahead and add those arrow markings on there. Okay, let's see what we can do with these theorems and being able to work through some problems. So in example 1 on page 226, we see a diagram with four different lines intersecting, lots of different angles that are labeled here, and we're asked to use given information to determine which, if any, lines are parallel. And then, of course, to state the postulate or theorem that justifies our answer. So we're going to take this diagram and apply it in these three cases. First off, if we knew the relationship that angle 2 was congruent to angle 8, go ahead and add that arc mark in pencil to the diagram so we can talk about their location and whether the relationship is what it should be to use our converse. Angle 2 and angle 8, you guys, are alternate interior angles. I'll abbreviate interior angles. And that is off of lines A and B with, notice, both touching the transversal of line L. It's going to be important that we identify which is the transversal that's creating both of those angle spaces. So because alternate interior angles are congruent, then A is parallel to B by, and we give that our alternate interior angles with a C at the end for converse, because our logic is flowing in that direction. In part B, our next pair of angles is 3 and 11. This would be a great example of what we talked about where we were using the tool of patty paper. If you need to retrace this diagram here and start over with some new arc markings. I know we already filled in one pair for A, so think about either erasing or redrawing the diagram so that you can locate what we need to with a fresh look here at this interaction. So angle 3 and angle 11. Think about what lines and what the transversal might be that create those pair of angles. Well, they are both formed off of the transversal that is line A, and they are formed by lines L and M. Those are going to be corresponding angles of lines L and M. And because the relationship is that corresponding angles are congruent, those lines L and M are parallel, and we can do the corresponding angles converse as our justification. And in our last part of example 1, choice C here, we're looking at angles 12 and angle 14. So if we know that those two angles are congruent, then we can go off of the relationship that this is our transversal of line M, and that those angles are formed by lines A and B. The location relative to those three lines is that these are alternate exterior, I can spell, exterior angles, abbreviate that. And so because those alternate exterior angles are congruent, those lines A and B are parallel by alternate exterior angles. C at the end for converse. Take a pause on the video and see if you can do the same here in the check with 3 fresh examples. This time we have some multiple choices where you're choosing the pair of lines that might end up parallel and the reason that justifies it. And also we have also some fill in the blank problems as well here for part B. So see what you can do with that. In example 2, we're going to begin to apply some algebraic relationships to these diagrams using converses. So in example 2, we're asked to find the value of y so that E is parallel to F. Well, if we look at our relationship with the markings here, we can see that line D is perpendicular to line E. And for lines E and F to be parallel, line F also needs to be perpendicular to D. So that would form a 90-degree angle on the other side of our 4y plus 10. So that leaves 4y plus 10 is also equal to 90 degrees. So if we go ahead and fill that in, starting with our definition of perpendicular that gets us there, and we subtract 10 from each side, we're going to get that 4y equals 80. And if we divide both sides by 4, we get that our y equals 20. In this particular example, all we were asked to do was to solve for y, so this would be our answer. Depending on the type of problem that you are asked, make sure that you are either solving for the variable or possibly solving for the measure of some angle as well. Take a pause on the video and see what you can do with a couple of these examples of finding missing values. In example 3 here on page 228, if you've lost track, we have an example of lines and a transversal that's kind of superimposed here onto this rowing picture. So to move in a straight line with maximum efficiency, rowers' oars should be parallel. If we look at the photo at the right, is it possible to prove that any of the oars are parallel? So let's see how to reason through this one. Well, the angle that forms a linear pair with that lower angle that is 50 degrees is going to, of course, be the supplement of that 180 minus 50 or 130 degrees. And that angle 130 would be a corresponding angle to the 124-degree angle at the top of the picture. Because those corresponding angles, however, are not congruent, this is not going to follow our corresponding angles converse. So the lines are not parallel, and therefore it is not possible to prove that these oars are parallel. In our check for example 3, we have another kind of transversal and line diagram superimposed onto this picture of the antenna complex. And we're asked, is it possible to prove that the support poles of this antenna complex, support poles being here and here, are parallel? And we have some multiple choices to choose from. They start here on this slide and continue on to the next. Make sure that you are changing each of those wordings in A and D. Instead of consecutive interior, we have same side interior. See what you can do with this one. Okay, everyone, this is the part of the video where you really want to check back on the answers to those checks that were assigned to you as you were watching. All right, in our check for example 1, back on page 226, we are comparing first in part A here, angle 1 being congruent to angle 15 and discovering whether that tells us any lines are parallel. So if we come over here and we say that angle 1 is congruent to angle 15. And here is a great reminder that if you need that tracing paper, that patty paper, to go ahead and redo this diagram in the next two examples and have new markings on there to talk about and compare, that's a really great strategy and a really great tool that you can make use of in your classrooms. So part A, angle 1 and angle 15, if you'll notice, are formed by all four lines, not just two lines and one the same transversal, right? So these lines that are forming them, for one way to think about it is that it's line L and M that are forming the angles, which is, normal that we have two different lines creating that angle space. But notice, unless we have line N and line K, we don't enclose those angle spaces at all. So what that means, you guys, is really that there is no single transversal. And if there is no transversal that creates that pair of angles, then it is not possible to determine whether those lines are parallel. In part B, we're looking at the measure of angle 3 and the measure of angle 10. I'm just check marking these because we're told that these are not congruent to each other, but that they have a certain relationship. So angle 3 and angle 10, if we look at where those angles are located, they are both off of line L as our transversal. So that's okay to think about a pair of angles. And then off of lines N and K, these angle spaces represent same side interior angles. And since they are adding to 180 or supplementary, the converse of that theorem tells me that the other two lines off of transversal L means that N is going to be parallel. We'll make a little script there. Remember, lowercase script letters. N is going to be parallel to K. In part C this time, and I will come back here and erase our or change color here, I guess is a better way to do it. Um, Change color to the new relationship we have in part C. So in this case, we're told that angle 3 is congruent to angle 5. So that angle relationship name, those are alternate interior angles. So notice we have choices for A and C that have alternate interior angle converse for the reason. So we'll get rid of B and D. Also remember consecutive should change to same side interior. We don't want to think about consecutive numbers being this always same side interior. That's not always the case in those diagrams. So then the question is, what are we looking at? Are we looking at L is parallel to M from these alternate interior angles, or N is parallel to K? Well, we didn't identify the transversal. Shame on me. Let's go back to the top. What would that transversal be here? The transversal off of angles 3 and 5 would be line N. Hopefully you can see that. Then what are the other two lines that would be parallel? That would be choice A. L would be parallel to M using the alternate interior angles converse. In our check for example 3, we have two algebraically labeled angles. The relationship between those two angles, if they were set equal in measure, because they are in corresponding locations, would be the corresponding angles converse would be able to prove that line M was parallel to M. So let's see what our value of X would be here. Go ahead and solve here, move our X's to the same side, constants to the same side. My X value should be 1. All right, in part B, we're asked to find the measure of angle LMN that makes line A and B parallel. We have a couple of different possibilities here, but I think the quickest one is to realize that the measure of angle RST here at 9x minus 12 is in an alternate exterior location to the measure of angle LMN, which is our 4x plus 6 expression. And if those alternate exterior angle were set equal to each other, were congruent, then those lines would be parallel. So we're solving another quick equation here. And X comes out to be 18 divided by 5, which is 3 and 3/5 as a mixed number. And then which of these decimals does that equal? That would be choice A. Remember to always identify that postulate as you saw in the stem of these instructions. Finally, we're asked, is it possible to prove that the support poles of the antenna complex are parallel? If we look at the measures 120 and 54, they are in same side interior angle locations. The question is, do they have the relationship that same side interior angles should have when the lines are parallel, which is that they are supplementary? Well, if we think about 120 and add 54 to that, that is 174, which is certainly not equal to 180. So we need to pick a no answer. This slide has both of our no answers on it. The next one has our yes answers. So we're ruling out choices C and D. Now the question is, which one of these reasons justifies our answer? So we definitely know that we're a no. Is the reason because the same side interior angles are not supplementary? Yes, that's exactly what we just proved with that quick arithmetic. Just to prove that we are on the right track, let's rule out choice B. This time that is no because they're calling them alternate interior angles that are not supplementary. And remember, alternate interior angles, converse, is saying that the relationship should be congruent anyway, not supplementary. So that's wrong in a couple of different ways. So not choice B, we have choice A for our answer. We'll see you in the practice.